3.0 gram of a mixture of potassium carbonate and potassium chloride were dissolved in a 250 cm cube standard flask. 25 cm cube of this solution required 40.00 cm cube of 0.1 molar hydrogen chloride for neutralization. What is the percentage by weight of K2CO3, that is potassium carbonate, in the mixture? We are given the atomic mass of potassium to be 39, atomic mass of oxygen 16, and atomic mass of carbon is 12. Solution. Yeah, this is a question on neutralization reaction. And the first thing to do in solving a question like this is to write out the chemical equation showing the reaction between the acid and the base taking part in the reaction. Here in this reaction we are given potassium carbonate, we have potassium chloride, and we have hydrogen chloride. So how do we go about writing out the chemical equation? Before we proceed, I would like us to note that potassium chloride will not react with hydrogen chloride. So therefore, potassium chloride won't be part of the chemical equation we'll be using. Hence, this makes the reaction to just be between potassium carbonate and hydrogen chloride. Meanwhile, potassium chloride is present in the mixture itself. So now to write our chemical equation now, we'll be taking potassium carbonate to be the base and hydrogen chloride to be the acid for the neutralization reaction. So let's start. So for the acid now we have HCl reacting with the base, which is K2CO3, to give. So we'll be having salt. Our salt here will then be potassium chloride. We have water, and then we have carbon dioxide as the gas due to the presence of a carbonate compound present in it. So now next thing is to check if the chemical equation is balanced. Let's start with the potassium here. Potassium, we have 2 atoms of potassium present, while in the product side we have 1. So to balance that, we'll be adding 2 here. So now for potassium, now we have 2 on both sides. Now let's check for carbon. We have 1 atom of carbon present here, and in the product side we have 1 as well. For oxygen, we have 3 atoms present in the reactant side, and in the product side we have 1 plus 2, which makes it 3. So oxygen is balanced as well. So now going back to hydrogen, we have 1 atom of hydrogen present in the reactant side, while in the product side we have 2. So to balance that, we'll be adding 2 here as well. So we have 2 atoms of hydrogen. For chlorine now, this 2 is also affecting the chlorine atom, so we have 2 atoms of chlorine atom present, and in the product side we have 2 atoms present as well. So we can say the chemical equation is balanced. So after writing a balanced chemical equation, the next thing to do is to write out the formula we'll be using. And to solve any question that has to do with neutralization or any question on titration, the formula we'll be using is CAVA over CBVB, which is equal to Na over Nb. Here Ca is the concentration of the acid, Va is the volume of the acid used, Cb is the concentration of the base, Vb is the volume of the base, while Na and Nb is the number of moles of the acid and the base respectively, and this is usually gotten from the chemical equation. So the next thing to do now is to write out the values given from the question. Let's start with the acid. Ca, the concentration of the acid. From the question, we are made to understand that the solution required 40 cm cube of 0.1 molar hydrogen chloride. So the acid now, the concentration of the acid is 0.1 molar. So we have Ca to be 0.1 molar. Then Va, we have that to be 40.00 cm cube. Then Na, number of moles of the acid. So going back to the equation now, we have Na to be 2, that is the coefficient of the acid present in the equation. So now for the base, we have Cb. Now the concentration of the base remains unknown. Then Vb, So now we are made to understand that 25 centimeter cube of this solution, so that's the volume of the base that reacted with the acid. So VB is 25 centimeter cube. Then NB, now from the chemical equation, NB, that is the coefficient of the base here, is just 1. So let's proceed. Now we have Ca, Va, Na, Vb, we have Nb, but Cb remains unknown. So to get Cb, we'll be making Cb the subject of the formula. So yes, Cb is equal to, from the formula written above, we'll have Cb to be equal to CaVa times Nb divided by Vb times Na. Now the next thing to do now is to substitute the values. So we have Cb to be equal to Ca, which is 0.1 molar, multiplied by Va, 40.00 centimeter cube, multiplied by Nb, which is 1, all divided by Vb, which is 25 centimeter cube, multiplied by Na, which is 2. So from here, we have Cb to be equal to 4/50, then the unit molar, which is equivalent to 0.08 molar. This can also be regarded to as 0.08 mole per dm cube. Now this is just the first part of the question. Let's go back to the question. From the question, we are asked to calculate the percentage by weight of potassium carbonate in the mixture. So to calculate the percentage by weight of potassium carbonate, we need to know the mass concentration of potassium carbonate in the reaction itself and that of it in the mixture. From what we just did now, we've gotten the molar concentration of potassium carbonate. So the next thing to do now is to calculate the mass concentration of potassium carbonate in the neutralization reaction. Let's proceed. To calculate the mass concentration of potassium carbonate, we'll be using the formula, which is molar mass is equal to mass concentration divided by the molar concentration. So we've gotten the molar concentration of potassium carbonate from what we did earlier. The mass concentration is unknown, and that's what we'll be calculating. And for the molar mass, we'll be calculating that now before we proceed using this formula. So molar mass of potassium carbonate, which is K2CO3, will be equal to, that's the sum of the atomic mass of each atoms present in the compound. So for potassium, the atomic mass of potassium is 39, and we have 2 atoms of potassium present. So we'll be having 2 times 39 plus that of carbon is 12, and we have 1 atom present, plus we have 3 atoms of oxygen present, and the atomic mass of oxygen is 16. So that's, we'll be having 3 times 16, which is equivalent to, we have 78 here, plus 12 plus 48, and that gives us 138 grams per mole. Now after doing this, we've gotten the molar concentration from the previous calculation. To get the mass concentration, I'll be making mass concentration the subject here. So hence we say mass concentration of potassium carbonate equals the molar mass times the molar concentration. So from our calculation, the molar mass of K2CO3 is 138. So we have 138 grams per mole multiplied by the molar concentration, which is 0.08 mole per dm cube. And this gives 11.04 with the unit to be gram per dm cube. So now we've just gotten the mass concentration of potassium carbonate. Now we are yet to know the mass concentration of the mixture. To do that, we'll have to go back to the question again. From the question now, we are made to understand that 3.0 grams of the mixture were dissolved in 250 centimeter cube. What quantity of the mixture will be dissolved in 1000 centimeter cube? That's how we'll be getting the mass concentration of the mixture. So if 3 grams is dissolved in 250 centimeter cube, what mass of the mixture will be dissolved in 100 centimeter cube? So this will help us to calculate the mass concentration of the mixture itself. So to continue from where we stopped, we'll be using the relationship that if 3 grams of the mixture is dissolved in 250 centimeter cube, then S grams of the mixture will be dissolved in 1000 centimeter cube. And to get S, we'll be cross multiplying. So we have X to then be equal to 3 grams times 1000 centimeter cube divided by 250 centimeter cube, which gives 12 grams. This implies that the mass concentration of the mixture is then equal to 12 grams per dm cube. That is, 12 grams of the mixture will be dissolved in 1 dm cube, which is also equivalent to 1000 centimeter cube. Now we've gotten the mass concentration of potassium carbonate and we've gotten the mass concentration of the mixture. And the question says that we should calculate the percentage by weight of potassium carbonate in the mixture. So to do that, we'll be saying percentage by weight of K2CO3 in the mixture equals mass concentration of potassium carbonate divided by mass concentration of the mixture multiplied by 100, since we are dealing with percentage. Mass concentration of potassium carbonate, from previous calculation we've gotten that to be 11.04 grams per dm cube. Divided by the mass concentration of the mixture, which is 12 grams per dm cube, multiplied by 100. So this gives 92%. and that's the final answer. So with this, we can say that the percentage of potassium carbonate in the mixture is 92%. And that will be all on that. Kindly subscribe to this channel and also click on the notification bell so as to get notified as soon as new videos are being posted. Thank you.